Okay, now in this example, we have another CSRF vulnerability within an OAuth vulnerability. So kind of similar to the previous example, but it has a different twist to it. So let's approach it like a real pen test or a bug bounty, as if we're not really looking for anything specific. So as usual, you would want to come in and test every single functionality, including the blog. And then we're going to go into my account to test the login feature. You can see that we have a social login in here. As we said before, we're pretending this is a login with Google or Facebook. So we're pretending that this login is coming from Google, for example, and we're actually given the username and the password to log in with in here. It's Wiener Peter, similar to what we did before. So the username is Wiener and the password, I'm gonna cut it, paste it here. And before I log in, I'm actually going to go to the HTTP history. I'm going to select everything and I'm going to delete it, so that once we log in, we only have the requests that are being sent during the login or the authentication flow, so that we can analyze them and focus on them. So I'm going to click on sign in. And now the social network or Google or Facebook is telling us that the current blog is trying to access our profile and email information from the social network, from whatever social account that we're logging in with. We're going to click on continue to continue the authentication flow, continue one more time, and that's it. We're done. We're back to the main page of the blog. And if we click on my account, you'll notice that we're already logged in as the user Wiener, and our email is wiener@hotdog.com. So the authentication flow is done. This blog has authenticated us and allowed us to log in using our social account or using the social login feature. So the next step is to come in here and analyze the requests or the authentication flow. Now at this stage, we are pretty familiar with how this works. So you can see this was the first post request to log in. And then we have a request to /authentication. Then we have one for integration, with the most interesting two being this authentication and this callback, where basically after that we can see everything coming afterwards is just JavaScript and images. So basically the authentication is over. And if we look at the response for this one in here, you'll notice that it's saying you have successfully logged in with your social media account. So at this stage, everything is over. And if you analyze all of this, you'll probably not find any clues if there is a vulnerability in here. So this flow might very well be secure enough. So what I'm going to do right now is I'm simply going to log out and try to log in again with my social media account, because that is actually a different flow than the initial login. So in the initial login, our social media account got linked to this blog, but now when I'm going to log in, a different flow or a different exchange of information is going to happen. So maybe or hopefully that exchange is actually vulnerable to something. So before I do that, as usual, I'm going to delete all of the data in here in my HTTP history. And then I'm going to click on my account. And as you can see, it's automatically logging me into my social media account. This time I didn't need to log in because my profile is already linked to this website. And we're just going to click on continue, and boom, we're already logged in. So again, if I click on my account, I'm logged in as Wiener with wiener@hotdog.com. And right here now, because I deleted the history initially, I only have the data exchanged during the login flow, so not during the initial linking flow. And again, we're going to go over them one by one, looking for interesting information. So you can see that the first request was to my account, and then we made a request to social login, so that's all fine. The first most interesting request is this one right here, to /auth. And if you analyze the request in here, you'll see that there is a specific client ID that is being specified in here. And then we have a parameter called redirect URI. So the name of this parameter on its own is actually very, very interesting, because it's specifying a URI that the user should be redirected to. So if we can hijack that, then that on its own is a vulnerability. Now, if we read the rest of this, you can actually see that the redirect URI is a path on this current website. So this is the specified redirect URI. And if our theory is correct, if the user gets redirected to this URI, then the next request should be sent to this URI. And sure enough, if we look at our HTTP history, we will actually see that the next request after the current one is identical to the URI that is being specified in here. So this one is made to /OAuth callback followed by this code. And as you can see in here, it is being made to /OAuth callback, but without the code. So where is this code coming from? If we analyze this furthermore and look at the response, you will notice again a message saying redirecting to. You can see the full URI in here, including the OAuth callback, which we can see in here and we can see in here. And it's actually followed by the code that we see in the next request. So basically, this request right here to the /auth is specifying the URL for the next request in the redirect URI parameter. Not only that, but it's also returning the access token in its response. And then the next request is constructed in a way where you have the specified redirect URI followed by the access token. Now this is crucial because if we can hijack this redirect URI, if we can actually modify it, then we can have the access token delivered to us or to a server that is controlled by us. Let me explain this to you in our diagram to make this clearer. So originally, in normal situations, we know that the user will be presented with a social login. They're going to log into the account to the social network. If the login is successful, the social network will send an access token to the target website, and then the target website is going to use this access token to retrieve data from the social website. So the access token is what can be used to log in and retrieve data. Now, in our case, we can actually hijack this path right here by modifying this redirect URI. And if we do that, the access token is going to be delivered to the hacker's server. And from here, the hacker can actually use this access token to log in as the user. Now, there is a CSRF element to this because we need the admin to submit the forged request that we're going to create in here. So we're going to have to send a forged request to the admin with a forged return URL. The admin is going to log into the social site. Because of the forged URL, the access token is not going to be sent to the website. It's going to be sent to the hacker's server. The hacker is going to read it and use it to log in as this user right here. Now, creating this forged request is very, very easy because we already have the request in here. All we have to do is simply modify the redirect URI to the hacker's server or our own server. So we're simply going to right click this and copy the URL. We're going to go to our text editor, paste it, and we're going to replace this value in here. So the value that comes after the redirect URI with our own server. So you could have your own web server running anywhere, even on your own local machine if it's exposed to the internet. Or in this example, it actually comes with an exploit server. So I'm just going to open it in a new tab. And it's making your life easy by giving you your own server in here. So all we have to do is simply copy this server and paste it in here after the redirect URI. Paste it here. And we're done. So basically now, if a logged in user submits this request, the server is going to return an access token to the specified URL in here. Now we're going to have to put this in a HTML page to be used in a social engineering scenario. It's going to be very similar to what we did in the previous lecture. So we're just going to add a HTML tag at the top and a /HTML at the bottom. And we're going to put this link inside an iframe in the SRC. And I'm just going to close the quote and close the iframe. So in a real life scenario, you want to save this as a HTML page and deliver it to the admin and social engineer them to run it. But in this example, because it's a lab, we don't actually have a real admin. So again, they made our life easier by including this backend in here where it can mimic an admin clicking our HTML file. So all we have to do is simply paste the HTML content in here. We're going to click on store. And we're going to click on deliver exploit to victim. And that will mimic an admin clicking the HTML page that we created. So if this worked correctly, it should have sent the admin's access token to this URL, which is controlled by the hacker. It's simply a URL on a web server that is controlled by the hacker. Now, all web servers have a log. A log file contains all of the data, all of the requests that were sent to the server. So in here, we can access the logs by clicking on access log in here. So I'm just going to view the logs and we're going to scroll all the way down. And as you can see, we have a parameter called code, and the value of this parameter seems like an access token. Now, if we compare this to here, as you can see, the access token is actually being sent after the code parameter. So this is probably the admin's access token that we can use to log into the server. So now that we're at this stage and we have the access token, the next step is to use this access token to log in to the server. Now, there is no one way of doing this. This depends on the target website that you're communicating with, that you're trying to hack. Therefore, you have to get that answer from the burp history in here. So we know that this was the request. So this was the initial request that caused the access token to be sent back in here. And then this request was sent with the access token in it in order to log the user in. Therefore, we're going to use this very request to log in with our own access token. So we're going to right click this and copy the URL. We're going to go to our text editor. We're going to paste it. So this URL has pretty much done everything for us. The only thing we need to do is replace this access token with the one that we just stole with this access token. So we're going to copy this one. We're going to paste it here. We're going to copy everything. Go back to the target website. We're going to log out so we can log in. And then we're going to paste this URL that we just created. And if everything is correct, we should be able to log in as admin because we're specifying the admin's access token after the code in here. And as you can see, there's a mistake in here. There's code equals code. So that was a mistake. We just need one of these followed by the code. And we're going to copy all of this, paste it, enter, and perfect. As you can see now, it's saying that I managed to log into my social media account. But if you look closely in here, you'll see that I have access to the admin panel. And if I click on it, as you can see, I can actually delete users because I am logged in as admin. So we basically managed to log in as admin without the admin password, but using the admin's access token that we stolen through a forged return URL.